Folks, today, last day of class, we are looking at optimization. So we are automating the solver. A lot of times we try to start with a blank workbook. So you can get the feeling there's no magic here. We're just building from scratch. Not today. Today we have a full-blown application that has had the optimization part ripped from its innards, and we're going to build that part back in. So go ahead and download this Optimizer Start, Portfolio Optimizer Start, and open it up in Excel. It's opening, open. I will enable editing. And what I'm going to do is I'm going to talk you through what this application does. So right now we have here we've got a set of tickers. If you click on Add Tickers, it will open up a form and let you add more tickers. I used to use this example as a running example through the course, and so it's got a lot of different things in it, more than we really need for this particular example. And so however we get this list of tickers, we've got these ticker symbols here. The whole idea here is that we're saying, listen, I've got a bunch of money I want to invest into this set of stocks. And I'm expecting a certain return. I want a monthly return out of this portfolio of 1%. We're going to ask the solver to help us figure out what is the best way for us to allocate our money across these stocks so that we can minimize the risk, minimize the volatility of the portfolio, and still have our expected return meet whatever we've set as our threshold required. To do that, we're going to have to get some historical data. And so if I come to the you just come look at the Yahoo tab. The truth is, until, a couple of months ago, well, probably more like 6 or 7 months ago, I used to pull this data from this example from Yahoo. That's why this page is called Yahoo. It's from finance.yahoo.com. But then they've recently made it more difficult to get historical data. And so rather than solve that difficult part, I just found another site that was still easy to get the data from. So this data is actually coming from Investopedia, but it's going on the sheet Yahoo because that's the way the application was written to expect that sheet named Yahoo. So this brings in like monthly data for a particular stock. So here it is on March 13th, 20th of March 2013, the last trading day of March 2013. It looks like the closing for this stock was $76.44. Here's the volume that traded on that day. Or maybe that month. I'm not really sure. But that's the closing amount on that day. Well, it's probably that's the daily trading. A month earlier, that's what the close was. A month earlier, that's what the close was, and so forth. So I'm getting monthly reads of what this stock's price is. I'm then calculating the percentage change between the month. So between the first 2 months I have data for here, that percentage change was 0.6% increase, 0.1% increase, 4% increase, 2% decrease, and so just looking between those months, that's what these numbers are telling us. So we then take this monthly percentage change and we bring that onto the consolidate sheet. So for American Express, this is the vector of monthly percentage change. From Apple, this is the vector of monthly percentage change. Why is this interesting? I mean, why do I care about how this is changing month to month? In the back?
You can calculate the beta to a relative benchmark. And that's your measure of volatility.
That's right. So I can calculate the volatility. If this thing's all over the map from month to month, then all of a sudden I go, there's a lot of risk, but there's maybe a lot of upside, but potentially some big downside as well. And so that's the whole thing that we're going to ask the solver to optimize is to say, allocate these stocks so that we can minimize the volatility, to minimize the risk in the overall portfolio. And so these numbers are what underlies those calculations. We then have some summary data here where we're saying here's the mean return. That's just simple. It's just the average of all these numbers. The mean monthly return for this particular date range for American Express was a 1.1% increase. Every month, on average, they increased by 1.1%. Apple increased by almost 3% every month during this period. Oddly enough, this period from 2007 to 2013. By the way, would you want to invest today based on this particular date range?
No.
There's really two bad things to do. We have a finance guy going, yeah, this is not so bad. Maybe there's some good reasons to do this. But from my perspective, there's two bad reasons. What's the first bad reason?
It was prior to the recession.
This includes the recession, kind of right in the middle. It's a really unusual event to say, let's try to predict the next coming year based on the fact that we have the biggest recession in a long time in that data. And then number two, it's also pretty old. 2013, so this is our newest data is 5 years old. And so that just happens to be the dates that are in the example when we load. Now, finance guy.
I was just thinking 2007 is a great time to buy.
Oh, yeah, good time.
So, yeah, everything went down.
It's not as good as 2008. 2008 would be a better time. But anyway, that's fine. So we'll probably want to change these. I'm going to go ahead and change this to something that's a little more relevant. Maybe move this to 2009. And end in, 417, that's yesterday, interesting. 2018. We're only getting end of month readings anyway, so we won't go all the way up to 417. All right. Now, to be sure that this code is going to run, we're going to need to make sure that we've got this solver involved. So, step one, let's just make sure that solver is installed. For some of you may not even have solver installed because the solver is an add-in. It's not native capability to Excel. So we're going to come over here to the Data tab, and we're going to just look over here and make sure that solver appears here. Is there anyone who's on the Data tab looking at the far right, you're not seeing solver? You're all seeing it, but it might, good, someone's not seeing it, good. So I won't feel like we're doing this just for the video audience. So here's how we make sure that solver is available. We're going to choose File, Options. That'll bring up our Excel options. We're going to choose add-ins over here on the left, the second from the last choice, add-ins. And then down here at the bottom, it says Manage Excel Add-ins. Click on the Go button. And that will bring up your add-ins. You should be able to check the check mark on the solver add-in. Check that, say OK, and that should bring in that functionality. Now when we go back to the Data tab, we should be able to see solver right here. Does that show for you now? Okay, good. So, let's see, we were talking through this. So we've got the summary data here. This is a correlation matrix, also somehow involved in this particular model. Let me just take a minute and talk about what a correlation matrix is. A correlation matrix allows us to say, it's a measure of how these stocks move together. When I'm looking at their percentage change, when one increases, does its parent stock tend to increase with it, or does it not? Let's look at this one right here. This is really pretty highly correlated. There's a 76% correlation between American Express and Ford. That means when Ford goes up, American Express tends to go up. When Ford goes down, American Express tends to go down. Now, if the correlation is 1, that's a perfect correlation. That's what we see on the diagonal here. When American Express goes up, American Express goes up every single time. When American Express goes down, American Express goes down, and by the same amount every single time. That's why when we're comparing a stock with itself, the correlation is always 1. But as we get close to 1, we say, wow, yeah, those are pretty highly correlated. Here's another one that's a little lower correlated, Ford and Apple. They're still correlated, positive, so one goes up, the other one tends to go up, but it's not nearly as strong of a correlation as between Ford and American Express. You see that? Some of these are negative. There are not a whole lot of negative ones here, but some are negative. Here's one. Between Southwest Airlines and ExxonMobil. It's pretty weak correlation, 0.02, but that says more often than not, when Southwest goes up, ExxonMobil goes down. So they're correlated in a negative fashion. Well, that's all somehow figuring into our model, then, which is where we're going to be doing the optimization. So let's take a look here. So this says we've got the whole basket of stocks here. Right now, it is arbitrarily set out to 10% into each one. So one constraint while we're trying to figure out how should we distribute this basket is that if we're putting 10% into American Express, 10% into Apple, 10% into Ford, the sum of all those weights has to be 1, and that's what this cell is telling us here. So we've got a named range here called weights, and the sum of weights has to equal 1. So that's a constraint that we're going to ask the solver to respect for us. So that's one of the things we're going to do. Now, the second constraint that we're going to ask it for is we're going to say, listen, I'm going to specify a required return. So let's say that what I'm really interested in here is like a 1.5% monthly increase, 0.015. And the constraint that we're saying here is that the expected return, that's what this cell is calculating, it's the sum product of the mean return by the weight. Our expected mean return has to be bigger than our required return, greater than or equal to our required return. Another constraint. We're telling solver, listen solver, as you're fiddling with these weights, trying to figure out the right optimization, here, respect this. This got to equal 1, and we've got to have at least as much expected return as we have required return. Subject to those constraints, solver, we want you to fiddle with these numbers to drive our portfolio standard deviation down as far as possible. Let me just do that by hand so we can kind of see what the solver does. So I'm going to copy this and just put the value here so we can tell if I've actually improved it or not. Let me just take all of my investment in Apple. I'm going to run that down to 0. And I'm going to put all that into Southwest Airlines. 0.2. So now I'm putting 20% into Southwest Airlines, nothing into Apple. And have I increased or decreased the risk? Increased it. That's not good. All right, let's put something back in Apple. 0.1. Let's pick another one. I don't know. Let's just try ExxonMobil. Let's put 0 in ExxonMobil. That increases it too. So I'm not very good at this. But fortunately, the solver is really good at this. So, and it's going to do that same process that we just did. It's going to fiddle with these numbers, making sure that the changes conform to the constraints that we have here. And it's going to check to see, did that increase or decrease the standard deviation? Because we're going to tell it we want to reduce the standard deviation of this portfolio as low as possible, subject to the other constraints. So that's what we're going to ask solver to do. The whole point here is that we're going to ask solver to do that multiple times. In fact, what we want to ultimately do here with this over here on our Frontier tab is we want to see multiple readings. We want to say, what if I have a really small required return? What's the best portfolio? Let me run that return up a little bit to another number. What's the best portfolio? Let me increase the return a little bit more. And so it'll say, this will build me a table that says, well, depending on how much return you're requiring, you should be able to accept more or less risk, and then we should get that plotted here. Right now, it's all fixed to the same value, so it's got a straight line. But we should expect to see some kind of curve here that will tell us you can, as you pull on more risk, you should be able to have a higher expected return. Okay. Questions? Go ahead.
The x-axis is risk, and the y-axis is expected return in this case. Then.
So here, yeah, it'd be good if when I built this chart, I would have put the axis on. So here, our required return goes from 0.02 to 0.02, 0.002 to 0.028, 0.028. Yeah, so this is the scale. This scale here is the required return, and then this is the portfolio standard deviation.
Okay.
Okay, so let's come back to our model, and let's run this solver once by hand. We're then going to run that, configure that solver again, recording ourselves doing it, and then we're going to dive into the code and see what we have to do to manipulate the code to get it to behave nicely. All right, so on my data tab, I'm going to open up solver. And so now solver is saying, great, we are, solver's objective is to either minimize some number, maximize some number, well, you don't maximize a number, maximize an expression, minimize an expression, or try to get as close to a particular value as possible. In this case, that's called the target cell, or the objective. So what is my target in this model? D14. Yeah, it's D14. It's my portfolio standard deviation. And so I'm just going to select D14, and that's my objective. And that is a measure of risk. The higher this number, the more risk. The lower this number, the less risk. So what do I want to do? Maximize or minimize? Minimize that number. So we'll choose minimize here. Now, I can't get that to change, that expression to change, unless I'm changing some values. And that's what this next part is right here. So this says, what values do you want to change? And we're allowed to change all of these weights. That's what this weight is designed for, is to say how much. What proportion of my basket, my portfolio is going to go in each one of these stocks. So that's what it's allowed to change. So now we've got to tell it what the two constraints are. And our constraints are, however you change these, they have to sum to 1. And make sure that our expected return, D10, is greater than or equal to our required return over here in F2. So let's add those constraints now. So I'll click Add a Constraint. It says, great, I'm going to take sum of weights, has to be equal to 1. If I clicked OK, it would take me back and I would say add another constraint. Or I can just say add, and that saves that constraint. It says, now what's the next constraint? And that's this one. Our expected return has to be greater than or equal to our required return. I want you to notice right here that something a little bit weird. Let's put an equal sign on the front of this. That equal sign is going to be a little bit important to us. When we look at the code, we're going to have to think about that. But I wanted to point that out. It's actually put an equal sign, like it's making a formula here. We'll come back to that in just a minute. So I'll say, okay, those are our two constraints. Now it turns out I have an option here to make unconstrained variables non-negative. So that's going to prevent these from putting in any negative numbers in here. So we want those to be positive. That looks great. This solving method here, there's 3 different engines that we can use for doing this optimization. I don't know the difference. We're just going to choose the default one here, GRG, nonlinear. I don't even know what GRG stands for. Anyone know? Anyway, we'll just default to that. That's fine. And we'll go ahead and say solve. Now, if it solves, we should expect to see several things we should expect to see. Number 1, these should change. So my weights should change. Number 2, we should still sum to 1. That's a constraint. Number 3, our expected return should be greater than or equal to our required return. And number 4, this should be less than it is. Okay, so right now it's 0.07. I think we're going to get down to below 0.06 as well, so we'll just see if that ends up being lower than this number here where I just copied and pasted the value. So I'm going to solve. It says solver found a solution. I'll say OK. Let's just make sure that all those constraints are met. Number 1, we're still summing here. It looks like a negative number, but what is that negative number? That's a teeny, eensy-weensy bit below 0. And so that is effectively 0, so I'm OK with that. With the solver, it's always an issue of approximation. And so that's effectively 0, so even though it's negative, I'm OK with it. And it looks like my required return was 0.015. That's exactly where my expected return is. And we're able to get the portfolio standard deviation down to 0.04. When we started, it was 0.06. So it's done it. It's reduced the risk while maintaining the level of return that I'm going to get, and it's allocated the whole portfolio. So that's what the solver does. You can imagine it would have taken me a long time to get anywhere near here with my guess and check method, because I was able to guess maybe 4 or 5 times a minute. It's going to guess 4,000 or 5,000 times a second to be able to do this. And so that's what it does. And every time it makes a change, it observes how the system behaves, and it goes, oh, probably shouldn't change that direction. We'll try changing that in the other direction. And that's what it does. Okay, any questions on solver? How many of you are looking at me saying, yeah, I was already totally comfortable with solver before you went through that? Oh, only about half. I would have kind of thought there was more in the script. Okay. So let's go ahead now and record ourselves doing that so we can get some code out of this. So I'll click on the record button. You can either go to the developer tab and choose record macro, or we've got the little record button down here. We haven't done a whole lot of recording lately. Got the record button down here. Macro 1 is a great name for it. I don't need a keyboard shortcut. It's going to make a new module. It's going to put this code in. We're going to go look at the code, and we'll move the code back into the application. So I don't really care about the name. We'll say OK. All right. I'm back to my data tab. Opening solver. Oh, and what we're going to see is that the solver model is already configured. It might be tempting just to say solve so I can get the code that solves the solver. And that would be okay, except what that means is that if the user comes in here and fiddles with the solver, we won't be able to know that it's changed. And so instead, what we want to do is we want to say with our code, blow away the whole solver model, because someone might have messed with it, and then rebuild it again from scratch. Fortunately, there's a button for reset all. So we're going to start with reset all. And it's just going to wipe out everything about this solver configuration. Now we'll go through that same process. Set our objective to be the portfolio variance. We want to minimize that by changing the weights. Subject to our two constraints. Sum of weights equal to 1. Add. Expected return greater than or equal to required return. Okay. We're still checked here, that's fine. And nonlinear, that's fine too. We'll say solve. Should look about the same. And we'll say okay. And stop recording. Oh, I took through that kind of quickly, so let's just make sure everyone's caught. Okay, so let's take a look at our code. Alt F11. All right, Module 1 is the code that was already built here, so let's come to Module 2. And here's our macro 1. Let's just take a look at it. Some comments here I'll delete just to reuse my code. Now, as it turns out, so this functionality is an add-in to Excel. It is not native functionality to Excel. It was not written by the folks at Microsoft. Instead, it's written by the folks at a place called Frontline Systems. I don't know what Microsoft pays them for the use of their solver to distribute with Excel. Maybe nothing. They might give it to Microsoft just because it's a pretty decent solver. It's a pretty decent optimizer. But are there more complex things that you might want to optimize? Yeah. And so Frontline Systems is hoping that if and when you need a more complex optimizer, you'll just replace it with theirs, which you'll pay like $50 a month to be able to use their professional grade optimizer. And so as we're looking at this, I know sometimes when I look at the code that gets recorded by the macro recorder that someone at Microsoft wrote, I go, wow, that's unusual, that's kind of strange. It's even going to be a little bit stranger for this stuff that was written by these non-Microsoft. This first one's not too bad. Solver reset. Beautiful. Just going to reset the solver. I like it. And now let's look at this next one. So this is solver OK. So we have a statement here called solver OK. Set cell D12. Oh, D12. That's not the one I meant to do. I meant to do D14. Okay. Yeah, I did the variance. Turns out the variance will be okay. I think it'll do the same thing. But let me go ahead and put it as D14 just because that's what the numbers I have labeled later as being the standard deviation rather than the variance. So there's my target cell. That's not too bad. Min-max value equals 2. What's 2? Yeah, minimize. How do I know? That's what I chose. I chose minimize. You want to see what maximize is? I don't know. Go choose it and record. It's probably 1. Value of will be ignored because we're not going to a value we're trying to minimize. By changing now, this is our first problem. By changing B4 to K4, what's the problem here?
If we add an additional ticker.
That's right. This whole thing is designed to say, you know what, give me an arbitrary set of tickers and then build the model. And right now, our code says we're always going B4 to K4. That's where we're going to be adjusting. If we have fewer stocks, that's going to be a problem. If we have more stocks, that's going to be a problem. And so one thing that we could do here is we could dynamically figure out the column that we're ending in, right? Come over here to column 4, or row 4, go to the last column, do end to the left, figure out, we're in column K. But it turns out that this code that I've written to get us this far has a named range called weights. It gets dynamically set to the weights to the size of the model. So there's other code that's saying, figure out what we're going to be changing, and then call that weights. And so we're just going to change this from that fixed range to weights. And again, this works for us here because there's other code that dynamically sets what weights is equal to. It wouldn't be that hard for us to figure out column K and to bring in column K here. But weights is already there. It's using engine 1, which is that GRG nonlinear engine. And so strange name, solver OK, but we get it. We're configuring the solver. This next one's not too bad. Solver add, we're adding a constraint. We are saying G7 is going to be equal to 1. Beautiful. We're adding another constraint. D10 is going to be equal to, greater than or equal to our required return. Now, there's actually a problem in the way this records, but I want to see the problem first, and then we'll fix the problem. So there's an issue here we're going to have to come back to. Let's look at the next line. Solver OK. Set cell D12. Make it, minimize it by changing B4 to K4 with the nonlinear engine. Is that exactly what we had before? It is. I don't know why it records it again. So we just don't need it. So I'll delete it. Let's look at the next line. Solver OK. D12. Minimize by changing that range. Nonlinear. Exactly the same. We don't need it. Delete that. This one we do need. This is solver solve. This is the one that says, now that we've got it configured, run the solver to do what it does. All right. Let me go ahead and go back and set these to all 0.1 again. And I'm going to run my code to solve this. So I've got my macro here. I'm going to run this and let's see how it does. Say OK. Looks pretty good. We've got this constraint here this constraint is met. So we've got a low standard deviation, but there's a problem. Do you see the problem? Yeah. Sum of weights is coming out at 0.8. It's not respecting that constraint. Let's take a look at why. You may remember when we were setting up those constraints, I pointed out that it was dropping an equal sign in front of the formula. In fact, we look here, this is called the formula text. It appears that it doesn't need the equal sign in front of a named range, but it is going to need the equal sign in front of the 1. This is a bizarre little bug that we have to add the equal sign. It doesn't need the equal sign when it's just running inside the solver, but in code, we've got to put the equal sign there. Folks, that's my little gift to you. It took me 6 hours to track that bug down at first. It's a strange little thing. So now that we have the equal sign in there, we go ahead and reset these back to 0.1. I'll run this code again. We'll keep it. Now it's respected that particular constraint. I don't have a good reason for why that is. There's some clue here that it's looking for a formula. And so we're going to make that a formula. It would be just fine if we put an equal sign in front of this one, but it doesn't seem to need it for a named range. But because it says formula text, I have to put the equal sign there. Because who knows where else that might have some kind of problem. Go ahead.
So in other code, I would expect one constraint to override the other one. And so I thought that was going to be the problem. But does it do both these concurrently? It doesn't say, oh, because this is after that code, it will only do this one?
So good question. The question is, can we optimize with multiple constraints? And the answer is yes. It will do what it can to meet all the constraints. Is it possible for us to write constraints that conflict with each other? Yeah, we could say sum of weights has to be greater than 1. We could put another constraint that says sum of weights has to be less than 1. And so it's possible for us to make a set of constraints that it can't meet. But if it can meet them, it will work with all those constraints. Okay, one more thing that's a little bit annoying here. What is it? When I run this, what does it do? It puts up this dialog. I don't want it to put that up. Fortunately, on solver solve, I'm going to come here and hit space, and it's going to say, oh, look, you've got some options here, some parameters. This show ref, there's actually a separate report that you can make it generate that gives you some information about what happened during the optimization process. We're not going to show that one, but there's this one called user finish. It's a Boolean value, true or false, about whether the user has to finish has to close that dialog box or not. So what do you think? What should you put here for user finish? True or false?
False.
Let's put it in and find out. User finish false. Let's see what it does. No good. It's still there. So, okay. Let's change it to true and see what it does. Run it. Now it works just fine. So the name of that variable seems exactly backwards from how it should be, but that's again it's what you have to do with the code. All right. There's one more kind of gotcha on working with the solver. How many solver models can I have in my workbook? Anyone know? here's the question. What do you think? You think I can have 20? Yeah, I can totally have 20. But there's a constraint. And the constraint is I can only have one solver per sheet. There's no reason that I couldn't say, conceptually, I say, well, I've got this information right here on the top part of the sheet. A little lower, I've got another model built here. I want to be able to optimize those separately. The solver says, you get one model per sheet. In fact, the way the solver knows which solver model to work on is it is the one solver model that is built into the active sheet. And so the other thing that's a little bit unusual for us is that the sheet with the solver has to be active while you're configuring the model or while you're solving the model. And so we're going to activate, our sheet is called model. Let's make sure we've activated that sheet. So I'm going to come here to the top, and I'm just going to say sheets, model, not activate. Okay, so now I think we're in pretty good shape. We should be configuring this to behave the way that we want. Let's just go and take a little tour through the existing code. I'm going to come back here to Module 1. We're going to see what the code already does, and then we're going to integrate this code where it needs to go, and then we'll run it. So here, in Module 1, I've got a sub called show ticker form that just calls the show method of the ticker form. That's one. But here's the main one, build model. All this does is it calls a bunch of other sub-procedures. So we've got one called clear old sheets. Any guess what that does? It deletes everything but the ticker sheet. Just deletes the sheets. Build new sheets. Any thoughts? It just goes through and rebuilds the sheets. The idea here is that if someone's done something accidental to the model, as long as they left the ticker sheet in place, we should be able to recover from it. You deleted a sheet or whatever, messed up a sheet, that's okay. Blow them away, start again. Get data is going to go through and pull in all the data from Investopedia. Let's just take a look at this one really quickly. You'll see that it's the same stuff that we've worked with in our recent interacting with web servers. So it looks like I'm dropping some stuff on here. Oh, and then I'm calling another one called Get Historical Data. You find Get Historical Data. That's actually doing heavy lifting. And let's see, which approach did I take? So I've got HTTP defined here somewhere. URL equals this. Oh yeah, set HTTP equal to create object. So I think we saw this on our third day of working with the internet things. We're using the Microsoft XML server object to be able to send requests right back and forth. We like this one because it is really fast. This is all publicly available data. We don't have to log in, and so it's really our best choice. And so we've got some URL that it's reading the ticker in, that gets passed in. We send a request, and then we read that data off of the HTML result and drop it onto the sheet. So again, we're not going over that content here, but it's the same kind of stuff that we've done before. Might be an interesting thing for you to look at sometime. Question here?
Yeah, in the Project Explorer, you have a folder called References, and we haven't seen that before.
Oh, very interesting. Reference to solver. Yeah, you know what? I've never really paid attention to that myself either. Presumably, that is because this is a reference not to something that's kind of built into Windows, but it's to an add-in. So my guess is that this is showing the reference to the add-in.
Like what we normally would do with tools and then references and add.
Yeah, actually we still have to do that. Good point. Let me take a look at that. So we've got to say tools, references, and you've got to reference the solver add-in. So it's already done on this one. But if you're starting from scratch, you're going to have to reference that solver. But you're right, we don't normally get this reference, and so my only guess is that's happening because this is a reference to an add-in, not a reference to native Windows code. Okay, once we've got the data, we're doing the summarizing, which is actually building our summary sheet and building our model. And then we've got config solver and run solver. Those are blank. So here's run solver, empty. Here's config solver, empty. And then after it runs the solver and configures the solver, we then have our find frontier, which we'll talk about after we get this code built in. So we are separating config solver because the idea here is that depending on the number of stocks that we've selected, we're going to have to configure that solver to be able to be the right width for that particular model. But once it's configured for that number of stocks, we might want to run this model multiple times with different criteria. So, in fact, it's what we're going to do, what this code is going to do, is it's going to say, well, let's pick a low expected return. Let's calculate that. What risk do we have to take on for the low expected return? And then it's going to say, move that up again and recalculate. Move it up again and recalculate. It's going to look and get us several measures across that. And so our configuration has to happen once, and then as we're changing the values in that configured model, we want to execute it multiple times. So that's why we have run solver separate from config solver. So let's go ahead and bring in the code that it takes to configure the solver. Go back to module 2. Let's see. We've got to activate, reset, do all this. Solver add. It looks like everything except the very last line, solver solve, is part of configuration. I'll copy that, bring that back to module 1. I'm just going to drop that right in here to config solver. Now, that just means our last line has to go in for run solver. Solver solve true. One more little thing I have to do here. What is it? Something that we've already talked about, but because we split our other procedure into 2 different procedures, it's going to have an implication for us. Do you see what it is? I think I heard it over here. What was it? We have to activate that sheet. So whether we're configuring the solver or we're running the solver, it has to be, the reason that the solver knows which model to work with is the model on the active sheet. So we're going to activate the model sheet whether we run or whether we're solving. That should be it. So we give it a shot. I'm going to come back to my code. I'm going to come to my ticker sheet. Let's see, I changed this to 2009 to 2018. That looks good. And I'm not sure if we're going to see it happen, but it's going to delete all these sheets, rebuild it, bring the data in. I think we'll see. I think we will see it today. So I'm going to click on Process Model, and it should do that. Here's the consolidate sheet. Let's bring in American Express. I'm sure the folks at Investopedia are thrilled with this. Output on this data. Apple. It's not too bad. I'm only getting 10, so it won't take all that long. Once it's brought in all of those, it should build out that model. It should set up the solver. It should run the solver. And then it'll get to that fine frontier, and it should actually give us multiple reads. And we'll take a look at the results on that page here. There's 10, so it should go to column J. H is 8. Okay, so let's just come back and take a look at our model, make sure that it looks right. So this seems a little bit strange. Let's zoom in here. Look at how it's. It's put this all into Apple. What's going on here? Why would it put everything into Apple? Question or answer?
Does it have to do with the return that we required? And Apple's the only one that earns a return that high?
Yeah, so what actually happens is when we're in that whole thing, the fine frontier will run this model 11 times. It starts with a minimum return. This is the lowest performing stock here. And then it's going to say move 1/10 of the way to the highest performing stock. And so it's actually run through all of those, and it ends up with the highest performing stock. The only way I can expect to get 2.7% average monthly return on this portfolio is if I allocate it all to the highest performing stock. What if I want to get a 3% average monthly return out of this portfolio? There's no reason I should expect that. My highest performing stock is below that. But if I want to get to that highest value, my only hope is to put it all into the highest performing stock. And so this has ended up here, somewhere else. Let's go ahead and put it back somewhere in the middle. I'll put it again to 0.15, 0.015. This optimize button now should also be set up and ready to go. So I should run that, and that should give us now a different optimization that is somewhere here in the middle. And we can see that now has given us an expected return matching our required return, and it's reduced the risk. Question?
What happened to the covariance matrix? Because the covariance should be 1 for across the diagonal.
So right here we're seeing is a covariance matrix. The one we looked at was the correlation matrix.
I see.
So correlation matrix puts 1 across the diagonal. The covariance matrix puts the variance of this along. So this would be the variance just of American Express. So the covariance matrix is a little bit different. I'm not sure how the details of how they're related to each other, but the covariance matrix is what we need for calculating the portfolio variance. Okay, so let's look at the frontier, and now we'll be able to understand what this frontier is doing. So if we come back and look at the model really quick, so our lowest return here is 0.00328. And so when we look at our frontier, our required return of 0.00328, it says we can get a standard deviation of 0.00137 if that's all you're requiring, and that's how we're going to allocate it. We're going to move the required return. So what you're seeing on this line is you're seeing the results of one run of the solver model. That's what the find frontier does. It plugs in our expected return, it solves it, and then it records the output right here. So here's the weights. That's what we got. It then bumps that up a little bit now. So instead of 0.003, it's 0.005. And that's how we would allocate it. And so it just keeps making those changes, and that's how we end up then with this chart. So as I'm looking at this chart, I can think, I don't think it makes very much sense to be saying, you know what, I'm going to be down here in this low return. Do I actually reduce my risk at all by saying, listen, I don't need a 1%. No, I'm fine with a 0.5%. Does that make any sense here? No, because with the same level of risk, I can get right up here to about here on the curve before I'm taking any more risk. For sure, I don't want to be lower than this. I can't get higher than this. Right here's the highest return I can get. So I probably want to be somewhere on this curve, then depending on my tolerance for risk. It turns out I can be anywhere to the right of this curve. I can accept more risk without taking on any more expected return, but I can't get anywhere to the left of this. So there's no reason to come to the right of it. So I really want to be somewhere on this line. And this line gives me a feeling, you know what, I probably should be right around in here in terms of my expected return. If I'm really risk averse, maybe way up here if I'm a little more risk tolerant. So I've just said everything I know about the efficiency frontier for this problem. So if you have a question, ask your finance guy. So then this is solver. So this is why we want to be able to automate solvers, be able to say, for the two things that we've seen here, number one, the size of the model might change. And I've got to set it up to be able to handle the changing size. And number two, for solving this problem, one solution may not be enough. I may need to make, in this case, 11 different solvings. And imagine if I had lots of different portfolios that I was considering and examining. I might want to be able to kind of do this whole process multiple times and to do some kind of analysis between the output of these different models. That's optimizing the solver. Questions? That's automating the solver. Solver is doing the optimizing. Question here.
So I've noticed that in the Project Explorer, there's actually like a section for solvers, just like there's one for your workbook that you're in right now. Anytime you try to open it, though, it always says like it has a password. Is that the actual code that Frontline Systems developed and is just shipped with Excel?
Yeah, so the question is, what is this? Hey, what is this? Same thing here. What's this one here? Func res. These are both those add-ins. And so sure enough, this is, if you can figure out how to hack that password, by the way, this password's really pretty easily hacked. But if you're trying to hack this password, you would see the code that Frontline Systems wrote to be able to do the solving.
And then FuncRes is the analysis tool pack?
FuncRes is the data analysis tool pack, or data analysis tool kit. Other questions? One more thing that I want to talk about today that we didn't talk about last time, and you should see it somewhere. it's sort of related today because we're talking about add-ins. It turns out you now have the ability to create your own add-ins as well. You didn't know it, but you are like 30 seconds away from creating an add-in. It doesn't take much to create an add-in once you've got a VBA project. To make an add-in, let's go to one that has a ribbon built on. So I'm going to go ahead and close this. Close this one. Save as. Better call it Optimizer, Portfolio Optimizer Winter 18. And close. And I'm just going to open up our, we have something about meditation. So Ribbon 1 XLSM, when that is open, it gives us a meditation tab here. And we've got a couple of buttons. These other ones are interesting here, but what I'd like to do is take this Visual Basic app that we've created here and turn it into an add-in. What's the difference? So right now, if someone wants to get this ribbon modification and the code that goes with this workbook, I got to give them the workbook. And that makes sense if this code is tied directly to this workbook. But if I want to create a series of VBA procedures that are like general for my industry, so finance guy, you can imagine some kind of code that I just want to always have at my fingertips. Whatever workbook I have open. I'm not sure what it is, but I'm sure as a finance guy, you can probably think of things. It would be nice and handy if that was just always there. So instead of saying this, you have to open the workbook that has this code in. You want to be able to say, this code's always available. I don't care which workbook's open. In that case, what you want to do is you want to make an add-in. And so what we're going to do is we're going to take our meditation app and we're going to make an add-in out of it. Then you still got to get that add-in into the hands of whoever wants to use it. And then once they install it, it doesn't matter which workbook's open, that code will always be there. So, are you ready to see how to make an add-in out of this workbook? Set your watch for 30 seconds and let's see if we can do it in 30 seconds. Go. File. Save as. Change it from an XLSM to an XLAM. That's the hardest part, is finding XLAM. There it is. That is the add-in. And say save. Done. Was that 30 seconds? Less. Now notice that right up here, what's the name of this file? Ribbon1.xlsm. It did not change this. It exported this. It says, look, you've got a VBA project. You want to save it as an add-in? Great. We'll export the add-in. And in fact, I didn't really pay attention to where it put it. File, save as, XLAM. Yeah, it's actually put it into the set of add-ins. Users, GLN, roaming, Microsoft add-ins. It's put it where it expects to find add-ins. I could save it somewhere else. I'm going to email it to my buddy or whatever. I need to get it somewhere else. But then let's just go ahead and see what it takes to install the add-in. So I'm going to close ribbon1.xlsm. I'm back here at book 1. And you'll notice my meditation tab is gone. I'm going to just install that add-in. File, Options, Add-ins, Manage Add-ins down here in the bottom. And is that one showing here yet?
Custom ribbon. It's the third one now.
Custom ribbon W18. So there it is. It finds it here because it put it in the add-in spot. If it wasn't there, if I emailed it to us, we could still go there. We would just have to say browse, and then we'd go find it where we're looking for it. And that would bring it in here. But it's already here. Custom ribbon W17. So I'll cancel that, and I'll choose custom ribbon W17. Well, that's like the last time I did it. I don't think that's the right one. Yours isn't showing it. Is yours showing it there? Okay, so maybe we have to add. So I'm going to browse, and ribbon 1. That looks better. Ribbon 1. And now it shows that ribbon 1 in there. So it looks like from W17 I already had this in last week. Now that shows ribbon 1. I should be able to say OK. Should we take off custom ribbon? I'm not sure what that is. We'll say OK. And that should bring our meditation tab back in. That workbook's not there, but all the code from that workbook is here. And now it does not matter which workbook's open. That tab is just part of this installation of Excel. So we've installed the add-in. If you want to remember how to inhale, breathe in, exhale, breathe out. could save your life. Do you remember that? If you forget, oh yeah. If you want to get rid of the meditation tab, which I would be hurt if you didn't want this all around all the time. Same process, right? Just go unclick it, and you'll be able to.
After this week.
That's right. After you're finished with finals. Options. I probably should go ahead and take it off now too. Add-ins and uncheck. But so that's the way that you know how to make an add. There's other ways to make add-ins. So you can make an add-in just using like C# and Visual Studio. But even that is not the current way. Beginning in 2016, Microsoft made a new way to make an add-in. And the nice thing about these new add-ins is that they are available through an add-in marketplace. So you can like take your add-in and you can publish it to a marketplace. Either give it away free, or you can sell for it. You can charge for it. Let me just show you those really quickly. I'm going to come over here to Insert, and then we're going to come to Add-ins and My Add-ins. That might be available by default. I'm looking to My Add-ins. I don't have very many. I've got ScriptLab here. I can come to the store, and what we'll see is that there are thousands of add-ins available. Lucidchart has an add-in that will let you take the charts you built on Lucidchart and just drop them into Excel. You can also do that by copying and pasting them into Excel, but if you do that a lot, Lucidchart might be helpful. These add-ins are built using a brand new architecture for working with add-ins. It is actually based on web technology, so what you've learned in VBA won't be helpful, but the Excel object model is still the same. So ultimately, you'll have to get yourself down to a range, and once you have a reference to that range, it's still the same thing, right? It's still got a dot address, it's got a dot formula, a dot value. So object model, what you've learned, will still be there for you, but it really is a different environment. If you are a web developer, you're familiar with Angular or React, those are the environments that are native for this kind of app development, this kind of add-in development. And by the way, let me just go ahead and install the Lucidchart one. I'm going to show you how they end up looking here. I'll add a Lucidchart add-in. So you can see that this has a ribbon modification built into it. It just adds itself on the end of the Insert tab. And when I click on that, it opens up a window over here. And then this is the part that's rendered like a web page. Log in and sign up. I'm actually communicating with their web servers right here through this. Log in. It just becomes now native part of what's happening here. So this new platform is really kind of new and exciting. It's not nearly as capable as what we can do with VBA, but Microsoft, I think, is heading in that direction. I think Microsoft sees this as their intended replacement for VBA sometime in the next 10 years. We'll be developing that. It'll kind of compete. And the nice thing about this is VBA runs where? On the desktop platform. If you want to run it on like the web version, no VBA. You can run it on Mac, you can run it on Excel. How about iPad? No VBA. These add-ins are cross-platform compatible. So they can run where. Okay, I guess that's it for the recording.